Welcome to my class. In our last two classes, we have already solved few problem sums based on addition and subtraction of algebraic expressions. In today's class and in the next class also, we will be solving a few more problem sums based on multiplication and division of algebraic expressions. So let's get started. We will be solving this problem sums in today's class. So let's proceed one by one. The first problem sum says that we have to multiply three factors, where in these three factors we have three variables, as we can identify p, then we have q, and also we have r, and their different powers. So what we will do is we will separately multiply based on their type. Either it will be constant term or it will be variable, and there may be different variables. As we have seen in this problem, there are three different variables. So in the next line, we will separately first multiply the constant terms. First constant term is 4 by 3, then we have minus 1 by 4 here, and then we have 16. So we will separately multiply them. Then we will combine or group the terms where we have this variable p. So in the first term we have one p, then in the second term we have one variable which is p square, then in the third term we have again p square. So we will group them. Then separately we will group the q terms. So in the first term of that original expression we have q square, then in the second term we don't have any q, so fine. Then in the third term we have another q square, so we will combine them. Then if there is any other variable left to be considered, then we will do that. So in the first term we don't have any other variable that can be considered. No, p and q we have already considered them. Then in the second term we have another variable which is r, so r, and in the third term again we have another variable which is r square. So r and r square, we will multiply these two variables separately. So again in this line, the first term, if we multiply all these constant coefficients, then 4 and 4 will cancel each other. 3 and 16, we cannot divide 16 by 3 because 16 is not multiple of 3. So it will be minus 16 divided by 3, the constant term after simplification. And here it is p square, and then again another p square. We already have the idea of multiplication of powers or exponents. So here what will be, since the base is same, so their powers will be simply added as we are multiplying. So it will be p, and if we add the powers, it 2 plus 2 4 plus 1. P means p to the power 1, we know, so it will be p to the power 5. Then from this term it will be q, again the base is same, q, and the powers will be added, so it will be q to the power 4. Then from the last term here it will be, again the base is same, which is r, so 1 plus 2 it will be rq. So our final answer will be minus 16 divided by 3, then p to the power 5, q to the power 4, and r to the power 3, or rq. Now in the next problem sum, again we are multiplying here three factors. In this algebraic equation we have three factors where we are multiplying them with each other. Here the simplification will be same as the previous problem. Here first we will separately multiply the constant terms. So here 4 by 3, then here we have minus 5, and here we have 1/3 or 1 by 3. So separately we will multiply those constant terms. Then here we have three variables, as you can see here, u, v, and w. Here also u, v, w. Here also u, v, w. So three variables and their different powers. So we will separate the u variable first. So in the first term we have u square, then it will be multiplied by u. From the second term we have u, and then here again we have another u. Fine. Then we will multiply all the v and with their different powers. So here in the first term we have v, and then in the second term again we have another v. In the third term we have v square. Then we will multiply all the w. So here we have one w, then here we have w square, and again here we have single w, means w to the power 1. Now if we simplify this multiplication of the constant terms, here 4 is not a multiple of 3, and same is with 5 also. So here simply it will be 4 multiplied by 5, 20, and we have minus sign also, so it will be 20 divided by 3 multiplied by 3, 9. We cannot simplify this to any reduced or simplified factor. Now from the second term, it is again the base is same, which is u, so their powers will be added, 2 plus 1 plus 1, so it will be u to the power 4. Then here it is v square plus 2 plus 1 3 plus 1 4, so it will be v to the power 4. And then here it will be again w square, here we have 1, here we have 1, so 2 plus 1 plus 1, again w to the power 4. So the simplified answer will be for this expression or for this multiplication minus 20 by 9, then u to the power 4, v to the power 4, and w to the power 4. The next problem sum is also related to multiplication of two factors in this algebraic expression, but it is bit different, where a and b values are given. So finally we have to put the values of a and b, and we will get the value, the simplified answer of this expression in numeric form. So let's proceed with this solution. So here again the constant terms will be multiplied separately, so 2.3 multiplied by 1.2. the a terms will be multiplied separately, a to the power 5, and here it is a square. Then the b terms will be multiplied separately, b square, and here it is again b square. 2.3 multiplied by 1.2, it will be 2.76, so 2.76, and here base is same 8, so their powers will be added, so it will be a to the power 7, and then it is b to the power, it will be 4. Now the values of a and b which are given, we will put them. So 2.76 multiplied by the value of a is 1, so it will be a to the power 7. The value of b is 0.5, so 0.5 to the power 4, so it will be 2.76. the base is 1, whatever is the power, it will be 1 only, and 0.5 to the power 4, if we simplify that, it will be 0.0625. Now if we multiply these two terms, these two decimal numbers, then it will be finally 0.1725. so this is simple. Now the next problem sums is again about multiplication, and here again the values of x and y are given, and if we evaluate the three terms here in this algebraic expression, we find that there are only two variables, x and y, so we will not face any difficulty in simplifying this expression. So what we will do here is again the same thing what we did before. So separately the constant terms will be multiplied. So 3 by 5 multiplied by minus 15 by 4, and from the third term it is 7 by divided by 9, and then x terms will be multiplied separately, x square, then x, and then again x square, and we have y, here we have y, here we have y square, and then here we have another term y square. So we will simplify further. Here 5, and here it is 15 multiple of 5, so here the factor that will remain or will be left back is 3, and here 9, so it will be 3, and this 3 will cancel each other. So simplified constant term will be minus 7 divided by 4. We cannot simplify this further as 7 is not multiple of 4. Now here the powers will be again added, 2, 1, 2, so x to the power 5, and here we have 2, 2, 1, so y to the power 5. Fine. Now the values of x and y are given, so we will put them in this expression. So x is 2, so it will be 2 to the power 5, and y is minus 1, so minus 1 to the power 5. Now here minus 7 by 4, it's same, and a 2 to the power 5, so 2, 4, 8, 16, 32. 2 to the power 5 is 32, and minus 1 to the power 5, whatever is the power, if it is the base is 1, then it will be 1 only, but since it is -1 and -1 when we the power is even, then it becomes +1. Otherwise, if the power is odd, then it is -1, the minus sign comes. So since the power is here odd, so it will be -1, it will be 56. So this is the final answer of this algebraic expression. Next, the problem is related to division. Previous 4 problem sums were related to multiplication. This one is different, and that is division. Divide this algebraic expression by this algebraic expression. So this is divisor, this is dividend. Now what we have done here is we have rearranged the terms. Here the variable is x and it has different powers. So we have rearranged all those terms as per their powers here in the descending order, both the dividend and the divisor. So here it is 5x square plus 3x minus 1. The divisor has been written like this, and the dividend 10x to the power 4, then minus 19x cube minus 32x square, then minus 4x plus 9. The dividend has been written again in descending order of the powers of x or the variable. Now what we will do is the first term has the power is 4, and here the first term the power is square, and this is the highest power of the dividend, this is the highest power of divisor. So we have to multiply such a term so that the power of x square becomes x to the power 4. It matches with the power of this dividend. So x square means we can multiply another x square to get x to the power 4, right? So that means with this term we have to multiply x square. Now here the constant term is 5, here the constant term is 10. So we can multiply 2 with 5 to get 10. That means with 5x square, if we multiply another 2x square term, then the result will be 10x to the power 4, which matches with the first term of the dividend. Now if we multiply this 2x square, then we have to multiply this 2x square, this factor, with other terms of this expression or of this divisor. So here the first term of the quotient of this division will be 2x square. Now 2x square, if we multiply with this divisor, then the first term will be 10 and then x to the power 4, as we have seen just now. Now 2x square, when it will be multiplied with 3x, it will be 3 2s are 6, and it will be plus 6 as per their individual signs. And x square, when it will be multiplied by x, it will be x to the power 3 or x cube. Now 2x square, when it will be multiplied with or by minus 1, then it will become minus 2x square. Now what we will do as per the normal rule of division, so we will subtract all these terms from these terms of the dividend. So if we change the sign here, then it will be minus minus, here it will be plus. So 10x square then minus 10x square, they will cancel each other. Then minus 19 and minus 6, it will become minus 25 then x cube, and from here it will be minus 30 as minus 32 plus 2, so it will be minus 30 x square. Here we have 2 terms, and in the divisor we have 3 terms. As per the normal rule of division, we will take the other term from the dividend. Here we have 2 more terms that have not been used yet. So next term will be minus 4x. Now if we divide further, then it is 5x square and it is minus 25x cube. So here the power is x square. Now with x square, if we multiply x, another x, then the power of x will be x cube. And here the coefficient is 5, here it is minus 25. So x with x square, if we multiply x, then it becomes x cube. And with 5, if we multiply another minus 5, then that result becomes minus 25. That means with 5x square, we have to multiply another minus 5x square term to get minus 25x to the power 3. So the next term of the quotient will be minus 5x, because this is the factor that we are multiplying by. Now minus 5x, when it will be multiplied with the first term here, it will become minus 25, as we have seen, then x to the power 3. Now again minus 5x, when it will be multiplied by the second term of the divisor, then minus 5 and here 3, so minus 15, and here x and x square. Now here it is minus 5x, here it is minus 1. So minus 5x and minus 1, when they will be multiplied with each other, it will become plus 5x. Now again the normal rule of division will follow. We will subtract the terms of this expression from the first expression. So we'll change the sign, plus, then here it is plus, here it is minus. So minus 25x cube and plus 25x cube, they will cancel each other. Here it is minus 30, here is it is plus 15. So it will be, if we simplify their coefficients, then it will be minus 15, then it will be x square, then minus 4 and minus 5x, it will be minus 9x. Then we have another term here left to be used, so it is plus 9, that will fetch here, and then again it is minus 15x square and is 5x square. So x square and x square, the coefficient, the power of the variable are same, so we don't have to multiply by any other power of that variable, by any other term. But here the coefficients, constant coefficients, are different. So if 5x square, we want to make this as minus 15x square, then we have to multiply it by minus 3. So 5 and minus 3, it will make it as minus 15, and x square, it is on the right side also, it is x square, so we don't have to multiply by any other variable. So the next term of that quotient will be minus 3. Now minus 3 and 5x square, when they will be multiplied with each other, the first term will be minus 15x square, then minus 3 and 3x, it will be minus 3 3s are 9, so minus 9x, fine. And then minus 3 and here minus 1, so when they will be multiplied together, it will be plus 3. Now when we will subtract all the terms of the second expression from the first expression, then again we will change the sign. So minus 15x square and plus 15x square, they will cancel each other. Minus 9x plus 9x, they will cancel each other. Plus 3 minus 3, here the remainder will be plus 6. So of this division, where we are dividing one algebraic expression by another algebraic expression, here what we are getting, the quotient of this division as 2x square minus 5x minus 3, and the remainder is coming as 6. Now it's not necessary that for all the division the remainder will be non-zero value only. It may be that there may not be any remainder at all, the remainder will be 0. Suppose in this expression if it was 3, then if it was 3, then finally it would have been 3 only. So plus 3 and minus 3 would have cancelled each other, and the remainder would have become 0. So this is also possible. So in this class we have learned how to multiply algebraic expressions and how to divide also. With this I end today's class. Thank you.